I'm Jason Van Zanten, the Information Security Lead here at JAMF Software. We have our third-party security consultants here. They're here to talk about what we do as JAMF Software. They help us secure our products and services. So we have Daniel and Graham from NCC Group, and turn it over to them.
Thanks. All right, so yes, we're going to talk a little bit about the third-party security assessments that we help JAMF do for their products. As Jason said, I'm Graham Buckles. I'm a principal security consultant with NCC Group.
Yeah, I'm Daniel Mayer. I'm also principal consultant. We're both based out of Chicago. I've been personally working on some of the assessments, and Graham has as well, so yeah, we are quite familiar with the product.
So the kind of agenda for this is we're going to talk a little bit about how third-party assessments are performed in general, and then some of the things that we look for during the assessments. And then we'll go on to specific findings that we've actually found in the past while working on JAMF products in older versions that have all been fixed by now. And then we'll talk some about the security configurations that you can do, because JAMF is full of lots of options to configure it correctly, and then there'll probably be plenty of time at the end to answer any questions you may have. So let's get on with it here. So what is NCC Group? Who are we really? We do software security assessments, which mostly are penetration tests, code review. At the end of this, we look at the products, in this case specifically JAMF, and we report flaws we find. And then we also provide recommendations for fixes or mitigations or configuration suggestions to make it more secure. NCC Group does a whole bunch of other things as well: software escrow, the .trust domain, things like that. Obligatory link to the website if you're interested. So we'll get on to security assessments here. Right? We do ongoing security assessments, helping out Jason's team, pretty much for the entire product ecosystem. So Casper Suite, the web application, the configurations on the box itself, the configuration of the mobile device, so the actual binary and how it's configured on OS X and iOS, the JAMF Nation website, all the pieces that make up pretty much Casper. We've been helping them with security. So as I said, what is a security assessment really? Pretty much our job is to understand the application, which is by analyzing what it does, right? Looking at how users interact with it, looking at how the components themselves interact. So this will be traffic interception between components, user input, how you guys interact with it, how it's configured, so how the software itself, gets its configuration information and stuff. And then also, because we're the good guys and we're helping Jason here, he actually provides us source code, so we can do source code review of the product, looking for flaws that the outside would have a much harder time finding in the product. When we do assessments, we're limited by time, right? We only have so many weeks and so many people that we can put on a project, and so the more we can get into the product, the better the results will be. Unlike the bad guys on the outside that would be interested in this, who have pretty much unlimited time and patience to cut through whatever they want to do. So once we understand the application, we start playing with it in ways that it wasn't intended to be used, right? We'll fuzz things, send random garbage or not so random garbage based on how the input is handled. We'll do operations that are logically a sequence, and we'll do them out of order. We'll do things like that. I'm trying to think of anything else.
Well, we're going to walk through some of the examples.
Yeah, we'll walk through
along
examples.
The way. Yeah.
And then so after the end, as we do these testing, we look for results that would not be expected, right? So if we're looking for, if we're sending bad input, we're looking for the server to crash, or the user interface to be looking different, or the system to be in a unsupported state, and all. So here's some of the things we look for, right? Authentication, authorization issues. They're two different things, right? Authentication is how the system identifies you, right? And we list 2 here. There's a third one, but the most common one is that you and the system have a shared secret, right? It's a password, or a passphrase or something like that. And when you go to interact with the system, it's going to say, prove to me that you're Joe. And Joe will type in his password, and the system will be like, okay, this matches, and lets you in, right? Other things, passwords have been known to have problems, right? People don't make good passwords. The system doesn't necessarily, systems don't necessarily let you set great policies for passwords. And so passwords are kind of passé, right? More interesting things are adding a second factor, right? So, passwords are something a second factor would be something like device possession, something you have, right? And this could be the RSA key fobs that you use, to type in like a one-time PIN when you access a system. It could be, you setting up the system to send you a text message, when you try to log in and it sends you the code and then you have to enter it in as well. So those are a lot of the common ones now. The third one that's not on here, although it's very popular, right, would be biometrics, something you are. Things like Apple's Touch ID or iris scanners on the new Windows phones or anything else, right? Facial recognition. Some banking apps, when you call them up, they do voice recognition, right? All of these things are biometrics. It's some measurement of you that shouldn't be easy to forge by a bad guy, but it's not something it's just you. So that identifies you to a system, right? Authorization is now wholly on the system you're talking to side, where it says, now I know this is Joe, I know this is Daniel. What is he allowed to do, right? And so Daniel logs in and he's an admin, so he's allowed to, reboot the system. Whereas I log in and I'm just a regular user and all I can do is see, information, but I'm not allowed to reboot it, right? So issues with identifying you, am I able to figure out a way to pretend I'm Daniel because he has privilege and I don't, right? So can I identify myself as him? Or, for authorization, even though I'm logged in as me, are all the authorization controls, was there an action that was supposed to be limited to Daniel as an admin that now I can do as myself because a check was forgotten or a check was coded wrong or something like that. So there's a couple of different types of things here, right? I'm talking here about Daniel being an admin and me being a user, and I want to get his privilege. That's kind of like a vertical escalation. I'm trying to get higher privilege on the system. And this could be, me logging in as a user, trying to get to a higher level of privilege. This could be me as an unauthenticated user. I'm just a random person on the internet trying to get access to the system at all, right? Having no privilege to having any privilege. The other thing would be, say, for a banking app or for something, 2 users on a system where, I have information that I want to keep private, like bank records or something like that, and Daniel has bank records he wants to keep private, and we're still just 2 users in this case now, but I want to get access to his bank. So I'm not actually getting any more privilege necessarily, I'm just getting access to information that isn't mine. It's another way you can do authorization, cross-authorization attacks. Well, another one, and this covers a lot of different kind of flaws that we find, would be injection flaws. In general, when anybody, whether it's us testing an app or bad guys trying to break an app, the application itself, whether it's a website or the binary on the system that's providing the security or the configuration, it's a big black box, right? Most of the time, attackers can't see in the box. They can send input in, and they can see the results of what happens. Sometimes, not always, but most of the times there's something they're looking forward to. Looking for coming back. And so all they have to be able to do is mess with the inputs they have access to. And so this causes a number of different kinds of attacks depending on what those inputs do. Right? So if I'm able to input HTML, raw HTML in a page, and it goes through the system and comes back somewhere else that I can write raw HTML to an output page, well, this leads to things like cross-site scripting, right? SQL If I can put SQL statements in and it gets sent to the SQL server without any kind of modification, just straight in through, that leads to SQL injection, which could lead to all kinds of bad stuff, losing databases, remote code execution, all kinds of stuff. Pretty much anywhere where user input goes in, is a potential point of attack, right? It's potentially vulnerable to content injection attacks. So HTML, SQL, LDAP, XML, JSON, you name how your input comes in, there's at least one attack probably that is related to not properly checking that input. Some of the issues here, of course, are that users aren't always aware, and developers aren't always aware where their input is coming from. I'm sitting at a web browser browsing into, the JAMF Nation website. Well, I'm just typing my username and password. However, the browser now is sending a ton of information, headers, other kind of bits of information to the other side. If it's going over SSL, we're talking like cryptographic exchanges, right? All these protocols and data that are from the user, that a user really never sees and are quite often forgotten about by developers because they're either handled at a higher stack level, right? Most people don't code SSL handling themselves. They rely on the server to do it correctly, or some other layer to handle it, and it's just forgotten about. So these kind of issues will sneak in at times where everything is written well at one level, but the next layer up or the next layer below, it wasn't considered, and then sometimes we can worm through to get to those layers and all. Speaking of SSL, another one is cryptographic flaws, and just to jump to the very last bullet here, don't do it yourself. We'll say that right away. Cryptography is used for three things mostly. Two of them are the most common uses, which is protecting your data from people who shouldn't see it and making sure that your information is not changed in transit. The third one is things like non-repudiation or identifying who you're communicating with and stuff like that, right? And don't do it yourself, right? So cryptography is hard. There are lots of algorithms out there. There are lots of algorithms that have been invented in the past that are now considered weak. It changes day to day. There's lots of ways to have a good algorithm but use it in the wrong way. There's lots of ways to have the right algorithm and the right way to use it and still manage your keys wrong. And that's just using ciphers that have actually been designed correctly, right? Once you start adding in people who like to design their own ciphers, who think that they have an unbreakable encryption method, it goes out the window, right? There's so many ways things can go wrong here that just by limiting yourself to known good ciphers and known good uses of those ciphers at least gets rid of a lot of the complications, and it gets you down to having to worry about, like the bottom list here, generating your keys correctly, managing your keys. If you use the right algorithms in the right way, the hardest part about cryptography is usually how do you manage your keys, right? Where do you hide them? Where do you store them? How do you generate them? Where do you put them when they're not in use? How do you get them back when the system starts? Things like that. You start making your own cryptography, it's a bad idea. So again, reiterating, don't do it yourself. Really. And then the last slide at the moment that we kind of look for is dependencies on other pieces of this ecosystem, right? Nobody builds a full stack themselves. I kind of mentioned this when I was talking about SSL, right? Nobody does SSL handshakes by themselves. They use OpenSSL, or they use, they use an Apache mod to put OpenSSL in place to do it all for you, right? So now your site is dependent on their security, right? And those components may be developed with different security, measures in place. They do their own bug triage, they do their own release cycles, they do their own validation, right? And so now you're gonna have to start keeping track of all of these things. You're running a website, you've got to keep track of, we're running it on Apache or on Nginx, we're running it using PHP or Twisted or one of the other frameworks, right? Are they secure? We're using third-party plugins into those, either open source or commercial. How do we keep track of all of these dependencies? And it matters because their security now is your problem, right? If they have something that breaks in their thing that's reflected on your website somehow, You use some input handling function of the framework and it does it wrong, right? You're now going to be popped. They don't care. They're a framework necessarily, right? They don't have a website. You guys do, or JAMF does, and it's important to make sure that you stay on top of how they announce their security fixes and how they incorporate them into their release cycle, so that you can make sure that it's included in your release cycle, right? So that's kind of the stuff we look for, and then that was more in the general thing. Here we can talk more about specific things we found in past assessments of the JAMF software stack. You want to take it over?
All right. Thanks, Graham.
Yep.
So we looked at all of those things which Graham just talked about, and I'm not sure how familiar people are with the internals on how JAMF actually operates, or the Casper suite operates internally, but there's a lot of these pieces going on where there's cryptography and certificate checking being used for the JAMF binary to talk to the JSS, and then there is mobile devices, and there's data which is being transferred between all these systems. So what Graham was talking about, injection attacks, is basically everywhere. A user may be able to submit something which will be displayed in JSS, and then be able to attack somebody who's an administrator there. And so we look at all of those things, and we just walk through just a very few findings which we found, just to give you some idea on what kind of issues we identified. I should note that all of those have been remediated pretty quickly after we reported them. So none of those, if you're on a recent version, should be there anymore. So the first one here was pretty interesting. In JSS, administrators have the ability to define a script or something which will be executed on all of the hosts which are being managed. And you as an administrator may not see this, but you basically just log into the interface, you paste in a script, or you upload a script, and then in the next run, when a device gets configured, it will pull down that script, and will execute it on the device to execute it. So in this particular case, the flaw which we found was that this script will be downloaded to a location which was accessible to any user on the box. So if this is like a MacBook or something like this, the file would be downloaded to /temp, and then would be executed and deleted afterwards. And if you would put another file there, it would just be overwritten, so there is not really like an obvious thing which you can do there. The problem, though, was that if you're a malicious attacker, you can write a script, shell script, in that location. For example, in this example here, we simply call whoami to see as which user this would be executed, and write that into some temporary file. And then you set the locked flag for the HFS file system on that file. So then no other process will be able to modify this file, so it cannot be overwritten. And what happens in the next time the check-in happens to apply the policy is that it will connect to the server, it will try to download the new script, it will fail to overwrite the file, and instead of executing the script which is supposed to be executed, it executes whatever the attacker placed there. And since the policy is being applied with root privileges, this will be run as root. So anybody on the host, on this box, could put a script there, set it as locked, and could put anything that would like to execute and will be executed with root privileges. So that was a pretty neat finding, I thought. It was not so easy to find. It took a while to get the trick with the locked and everything. The fix is actually pretty simple. Now JAMF just downloads this file into an isolated directory. That directory is ch-owned to root, and only root has write and read privileges to that directory. So you cannot put something there, or you cannot modify any file which is being downloaded there. So now you would need to be root on the system already in order to get this flaw triggered. And if you're already root, then we don't really care anymore, because you can do all the things which you could do previously. Another one here goes down to authorization controls, and this is I guess it's a bit more dry from the finding perspective. JSS uses a lot of AJAX requests to send changes which you do in the UI will be sent to the server in order to perform certain actions. And Graham talked already about this. There's like two components to this. There's authentication to identify who you are, and then there's authorization on what you're supposed to be able to do. And in one instance of JSS, you could have different organizational groups, and you can have different components where somebody has privileges to only one of them but not the other, and they should not be able to modify each other's resources. And what we found here is that one of those, that all of JSS itself thinks we're all right, but some of those AJAX requests, which the user doesn't actually see, which are happening in the background when you click buttons, there was not a proper validation check. It was not admin and profile, like I say here. This is just as an example. So one of those requests was not supposed to be working, and the other one should work, but we were actually able to issue that request manually and perform something for another user or for another group, which we're not supposed to. So the issue here, obviously, is that some malicious user could get access to somebody else's data, which they're not supposed to be able to get access to. And the fix, obviously, is really straightforward. You just add a check. So basically, instead of not caring about these AJAX requests or accidentally forgetting about a check, you just need to explicitly check this on any single action which performs some sort of state change in the system. You always have to verify that the user has the authorization which is required. The next one is a very interesting bug because it's not necessarily a coding flaw on behalf of the development team. It is more of a configuration issue. XML is, I don't know how familiar you are, but it's a structured language where you have different tags and parameters and things like that. And you can have so-called document type definitions, which are defining the structure of an XML document. And usually, people don't worry all that much about it when they're using it for the web. They basically just encode data as XML and sending it from the browser to the server, for example, for processing. The problem is, though, that XML is meant to be extensible and to be very flexible. So what it allows you to do is, in the XML message, you can basically define new elements and new fields which you would like to include in that XML message. So this example down here is defining a new document, which is just called foo, and has an element foo. And in that element, we're defining a new entity, which is just called XXE here, which we call XML external entity. And then we can give this a file or a URL. In this case, we just give it a file URL. And what that does is it defines, whenever you're using this entity, XXE, by referencing it like ampersand XXE semicolon, it will substitute whatever you defined as that string. But if you call it a system string like we have it here, it will actually go read that file from the file system and replace wherever you use that variable with the content of that file. So in this particular case, if you would send this message to the server would try to execute that definition for you, go to the file system, read @c password, and stick it in place of that XXE in the message. And if you get that message back, you actually will see the password file from the server. And it's a pretty prevalent vulnerability, actually, which is just, it's just crazy that this works and that it's the default configuration for a lot of systems. It was not really meant for being a security feature, I guess. And what you can also do, instead of having file URLs, you can use different kind of things. You could use an HTTP URL, and you could pull down a website from an internal server, even though you're completely outside the firewall. Or you could have this server potentially connect back to you and send something via FTP to you. There's like a really large variety of attacks you can do. Here's like a few other ones. You can actually try to access def random, which will read forever. So the server will try to read from there, and it will cause a denial of service because the request will never return. It will try to read from def random until it times out. You can request arbitrary files, as I already have showed you. And then you can access internal and external systems via HTTP or any kind of other protocols. Now the fix here is actually, as I mentioned in the beginning, it's more of a configuration change. All of the XML parsing libraries have a flag where you can disable these document type definitions or at least external entities. Some of them, I believe, in Xcode and the new development kits, they default to disabling some of those, but others are still enabled. So you always have to double check on what the default is on your system. The last one here, I believe, is related to encryption. And this one is used for password encryption. And what they're using here is or it has been used in the past, is the DES in ECB mode, which is the data encryption standard, and ECB is the electronic codebook mode. And what that does is that data is being encrypted chunk by chunk. So this is a so-called block cipher, and if it has a maximum, like a certain size, and if data is longer than that size, it will first encrypt the first part of that size, and then the next chunk, and so on and so forth. The problem with that is that there's actually a few things which are problematic. DES is pretty old, and it has a really small key size. The other one is that ECB is a very weak cipher mode because it does this encrypting each chunk separately, as I will show you on the next slide. And that makes it vulnerable to a number of attacks. One of them is, for example, if you look at this image here at the bottom, each pixel of this tux has been encrypted with ECB mode. And what happens is that for every input value which is the same, the ciphertext will be the same. So even though this right picture is encrypted, you still can learn a lot about it because you know, oh, this is black, I know all the other fields which are black. So if you use this to encrypt passwords, you can see, oh, this password is the same as this user's password because they both have the same ciphertext. And beyond that, there is a number of other risks which we have just by using ECB mode. On top of that, we have DES being used, which has a very small key size, as I mentioned, and people have built custom hardware where they can brute force DES keys in a pretty rapid way these days. So it's not a great thing to use for passwords. The ECB mode is not so much of a problem if you're encrypting something very short, which fits in one block, but otherwise it should not really be used. So the fix, first of all, if you want to store passwords and you don't need to recover them, if you just want to use them for authentication purposes, you don't want to use encryption. You want to actually hash the password. There are certain password hashing functions which are especially meant for passwords. So you stick a password in and it will take a long time to derive something which is being stored on the server. So if somebody gets access to this data on the server, they can not just try all possible password combination because each attempt will take very, very long. If you use encryption, because you need to have the password being recoverable, for example, if you're using it to store like credentials for a system, like in JAMF's case, if you want to encrypt the password which is being used, for example, for a recovery key for Filevault or something like this. If you want to encrypt that and you need to be able to recover it, you want to use something like AES for sure, and then CBC mode or something even which has integrity protection. And there is a variety of modes such as GCM. And all of those are available in like all modern crypto libraries, so you just need to use them. There is not really much else which you need to do. And then obviously you want to have a migration scheme that you don't lock out your users and get them enrolled in the new scheme as soon as possible. And then to the last point, which Graham was talking about, out-of-date software. He already talked about this in quite some detail, but the problem here is simply that there's a lot of system dependencies which you may have or which a software system can have, which you are not keeping track of. Because it works, right, and there is nothing breaks, there's no real issues with it, and you may have like a real huge chunk of different software which you're using, and each one of them can have security flaws. And there is like CVEs, as they call them, common vulnerability, what does the E stand for, enumeration or something like this? Yeah. It's a database where you can look up vulnerabilities which are publicly known for like basically everything, which is publicly disclosed. And if somebody figures out, oh, you're using an Apache which is outdated, you just can go there, find a CVE, and then you just Google for the CVE, and somebody probably wrote a proof of concept exploit for that, and then it's basically, you just need to be a script kiddie, as we call this, to just basically pop everybody who's running that software and getting access to the system. So this is a tricky thing to solve. You're basically just to look up away from being in the news by just somebody finding this information. So you need to keep up to date with all of these things. So subscribing to third-party mailing lists and integrating this into your software development lifecycle. And it's definitely a challenging thing to do, that you keep up with all those things while you're still developing. Because if maybe you update a third-party dependency which breaks your current build, and then you have to delay your release of the next version. So there is definitely issues with this. All right, so this concludes the part about like some sample vulnerabilities which we found and which have been fixed. This part here is about secure configuration recommendations. And what this is about is that since you probably all have used JSS here, there is a lot of options in there. And there's a lot of options not only for deploying a policy, but also just to how to deploy the system. And those are also there to support a host of different environments, right? Some people have different requirements and some other corporations have. But some of them are significantly less secure than other configurations are. So when we were going through our security assessment for this product, we were seeing, oh, this is not good, we should not do that. And then we talked to JAMF that, well, we need to support this for certain environments. So we tried to work with them to give them recommendations on which configuration they should recommend so that people have guidance on like how they should deploy it and that they have the most secure configuration if they're able to do that given their circumstances. So let's look at a few of these. The first one is message verification, and this is actually pretty low-level feature, so to speak, of JSS. This talks about the messages which are being sent from a host, like a OS 10 machine, that is checking into the JSS. It will send in a message for communication. And the problem here was that you could disable host verification, and that would allow anyone to request other hosts' information. So I could just pretend to be another host managed by the same JSS instance, and I'm getting data for that host instead of for my own. The problem here was simply, it's not really a problem, it's just that if you turn this off, you're not using the key which every JAMF managed host has to identify itself. So by default, they're having actually a pretty strong mechanism where you have client certificates on each host, and it will sign every message going to the server, and the server knows exactly who they're talking to. But if you're unable to deploy these client certificates, you may need to disable this in order to still use JSS, and then you come into this problem that you cannot isolate your hosts anymore. So basically, the recommendation here is to definitely use these client certificates. The second one was software installation, where this via the self-service or via other mechanisms, you can just offer software to be downloaded via many different protocols. So you can just say, install the software, download the software package from this host, and it could be an SMB host, it could be HTTP or AFP or anything else you would be liking to run. The problem from our perspective there is if you just give it a path, some of these are not encrypted, some of them don't even have like a checksum or like a cryptographic checksum or anything to verify that this data hasn't been modified. So if somebody gets access to a file share where a file is which is being deployed to all of your computers, potentially you could compromise all of them at once by just getting access to that file share and putting a file there. So our recommendation was to either switch to HTTPS or something which you can't modify in transit at least, and then potentially add on top of that certain integrity checks that you can have a hash or like a checksum on all of the data which can be verified independently by the client which is served by JSS. Well, and the last major one was the Filevault recovery key handling. So if you enforce encryption on an OS 10 machine via Filevault 2, there's two options on how you can handle the recovery key. Now there are three actually, but there used to be two. There's individual recovery keys, which are just generated by OS 10, and when you're just doing it manually, it's a string which is being output for you at the end, which you're supposed to be saving or printing somewhere. Or you can use an institutional recovery key, and that one works by having a public-private key pair for an organization. The organization has a private key, which they're not sharing, not even with JSS if they don't want to. They just give it the public key. And whenever you're doing Filevault encryption, the public key is being sent down to the OS 10 machine. It will use that key to basically encrypt the recovery key for it. And then not even JSS has the private key corresponding to the public key to decrypt the data. But if you're like an administrator and you want to decrypt data because somehow the password got lost, you can take your private key out of your safe, you can walk up to that machine, and you can use it to decrypt the disk separately. So the problem with the individual keys here was that in order to maintain usability, to ensure that the correct recovery key is in JSS, every time the host would check in, it will send down the recovery key so that it can be compared to make sure that it has the correct individual recovery key. And somebody who would be able to intercept data, for example, if you're considering a user who has root privileges on the box or something like this, would be able to get that recovery key and then potentially could decrypt data. So the institutional recovery key, because it separates encryption and decryption, is the better option here. So we kept this on purpose a bit short because we figured you may have some questions about what we talk about or in generally what we do for JAMF and what we have found to some degree. We may not be able to answer all of those questions, but yeah, feel free to ask whatever you have.
Sure, just talk loud.
So the question was that if you have an institutional recovery key, whether the danger is to get intercepted on the system or in transit. That depends on your JSS configuration is my answer to that. But if you're using the properly HTTPS secured with client certificate configuration, you should not be able to get that in transit. it would only be on the box. And if you have root privileges on the box, you can, if you have root privileges, you can bypass all those checks and you can intercept the traffic nonetheless. But only on the box, obviously, yeah.
Any other questions? I see hands somewhere here. We'll start over here.
Is there a way to turn off in JSS the checking of this key on the individual keys?
The question is there a way in JSS to shut off the use of, or to just shut off the checking or shut off the use of? Just shut off the checking.
Well, this has been a while since I looked at that, but at that time it was not. I don't know if Jason knows if there is.
Yeah, so if the JSS has an individual key for the box, it will check it during recon. Right now, there's no way to turn that off. So if you have institutional only, yeah, but right now, if it has both of them, it'll check the individual key at recon. If it doesn't have one, if all you're using is institutional keys, it obviously won't try to check something it doesn't have. Yep.
All right, next we'll sweep this way.
Apple gets a lot of press with their security around iMessage and FaceTime. Do you have an opinion on that? Do they build their systems, I guess, as strong as they say they do, where they don't manage the keys for decrypting these types of messages?
So the question is the encryption and security of iMessage and FaceTime as good as Apple claims it to be? I haven't actually personally looked at either iMessage or FaceTime. I don't think we actually have an answer to that.
Yeah, we cannot give you a real answer for that, I think.
Any other questions? Moving around this way, over here, back there, yes. No, you, yes.
Just a quick question, probably for Jason. Rather than sending a key down the wire, can you possibly do a hash of that key and compare it to the hash of the database? Transmit it, it's different?
I can answer that one, actually. So the question was, instead of sending down the key to verify whether that key is valid, can you just hash it and compare that you have the right hash? The problem is you can't, on the host, you can't retrieve the key again. The only thing you can do is say, hey, I have this recovery key, is that valid? So you basically have to give the OS X the key you have, and it will tell you, yes, that's good, or it's not. So there's just no Apple-supported way.
We certainly hope so. Did you have something more you wanted to say to that? Okay. Is there something I should know? All right, back there. Could you repeat that? I think I missed some of the beginning of it.
Did you assess it to be a vulnerability that for JSS, Apache Tomcat, and MySQL are not managed by the package management system, the operating system, and instead are sort of like separate?
I think it would depend, right? I mean, it would be something we'd point out, but there could be other mechanisms that are being used to manage that dependency, so it's not in of itself a vulnerability. If there was no management of it, I mean, we would definitely call it out, right? True, that is true. There could be legitimate reasons for that, though, right? You know, especially for enterprise-level software, where enterprises are somewhat leery of moving to an update immediately as it's released. You know, there could be a thing there. You know.
Yeah, like availability issues potentially.
Yeah.
We have some customers which are patching their own software. They don't even use packaged ones. They just imply patches by hand-picking them. So it really depends, I guess.
We'll go back over here now. Yes.
Can you talk about some of the tools that you use for penetration testing?
Sure.
Sure. So we use a lot of commercial tools as well as tools we write ourselves. So I mean, for doing things like web traffic analysis, we'll use intercepting proxies like Burp and things like that. But when it comes to like writing fuzzers, we usually end up writing our own. A lot of the times because proprietary products have proprietary protocols, and so we're not able to necessarily just pull a tool off the shelf. you know.
So I guess the goal for us usually is we want to see what's happening, right? So we want to see what communication happens between different components. So that's where what Graham's saying comes in.
Yeah.
Like a proxy allows us to see the traffic and the communication which is happening. And the intercepting part of it allows us to modify the traffic. So we can see a request coming from JSS and we can modify it and before it actually reaches the host or the other way around. And that allows us to see what we can do basically easier. That's like something, and that happens like on all levels. I mean, if
and it depends on the thing, right? Web traffic, fine, we'll use burp, you know. Regular network traffic, we'll use Wireshark or something similar to that. Proprietary traffic, we'll write our own like TCP listeners to catch it, you know. It all depends, right? You know, when it comes to host-based stuff, we'll write our own tools to like, you know, twiddle signals and things like that and see what happens. Yeah. And all. So it's a combination of commercial tools if they exist, because we don't have forever to develop our own. But if we need a tool, we'll write it ourselves.
Yeah. Especially for like long ongoing engagements with a customer, we oftentimes customize tools for that because we know we will have reuse use the next time around, and then we can get pretty specialized in that.
Any over here?
As a school district, one of our biggest concerns with any kind of internet communication is content filtering. And as more and more websites like Google and whatnot are forcing people to encrypted connections, we've had to implement a man-in-the-middle, authorized man-in-the-middle proxy. Do you see that as being a possibly undermining factor for any kind of security setup, since we're basically is giving out fake certificates at the edge?
You want to handle this?
Sure. First to repeat the question. So the question is, if you have a man-in-the-middle setup in your corporation which is acquired for content filtering, does that undermine the security of some of the communication? I think it depends a bit on how it's implemented. If you have your own CA, which is installed on whatever man-in-the-middling appliance you have, and you install that on the hosts, then that's probably more secure than if you would just tell the host to just accept any certificate by default. It may be, I think that's the best I would say to that.
You know, by definition, you're probably weakening security a little bit, right? Because now there's a bump in the wire, right? That, you know, if you have a malicious admin who wants to mess with traffic or read student traffic or do something bad, there's an opportunity. You know, but I mean, it's a known risk, right? And so you can take that into account with policies and stuff like that and look out for that. You know, above and beyond that, is it a security risk? Like Daniel said, I mean, if you're actually controlling the CA that's issuing those certificates, and so you can make sure that, you know, they're all being man in the middle, you know, but you are the man and you control the man in the middle. It's probably a very slight increase in risk, I would say. It's not zero, but it's not something that would be, I mean, so many companies do it because they need to, right? So, you know, there's a little bit of risk, but not insurmountable or unmanageable.
I mean, from like an attacker perspective, that's obviously a very fruitful target. So if you could compromise that host, you basically can man in the middle anybody's traffic in the whole organization after that. So it's definitely worth securing that box particularly well.
Yeah, keep the CA offline or something.
Well, but you need to issue a certificate for each request.
Yeah, okay. Yes?
I'm still a little bit puzzled with the way some certificates work. So with what we had a few years ago with the big vulnerability with OpenSSL, are you seeing any other encryption algorithms with certificates that appear to be problematic? Is there anything that you might recommend that we not use for terminating our SSL certificates?
So is there any recent guidance on certificates, pretty much? Right. All right. I mean, the one thing that pops off my head right away is the whole SHA-1 being pretty much declared extraordinarily weak, if not dead, for certificates. So if you aren't already moving forward to get new certificates issued using SHA-256, you probably should consider it. For those who don't know, there's been some cryptographic attacks on parts of SHA-1, which are making collisions much more likely in the near future than previously expected. Right. And so probably browsers will be moving their timetables up, I would think, but I'm not sure. As it was, Google and Microsoft and Apple were already planning to start, putting up screens saying this site certificate is old and insecure beginning next year. When exactly, I'm not sure. Like different vendors have different time frames. But now there's been some new developments against SHA-1 that have probably moved that timetable up. So SHA-256 for certificates. Otherwise,
Probably this is not really directly related to certificates, but if you're thinking about which cipher suites your server supports for terminating SSL, we usually don't recommend using RC4 anymore.
yeah.
It's not really broken, but there have been, it has been rapidly getting weaker with statistical analysis on that. So if we see it, we usually call it, it's not a high severity finding for us, but we definitely call it out for moving away from that.
Yeah. What are we right? ASGCM, right?
Yeah, ASGCM
And
is like the recommended one.
no. Good, yes.
Have you done any evaluations of JAMF Cloud or just self-hosted?
Have we
I think-
done any evaluations of JAMF Cloud or just self-hosted? You've done more of the evaluations than I have.
Yeah, I think we have actually most of the testing has been done on the cloud version. We always had a cloud instance for testing. We also had a local one just because we could go at it harder than at the cloud version. Yeah, but we definitely tested mostly in the cloud.
I guess my second part is, what would you say to an organization that wants to restrict access to pages of JSS externally?
What would you tell an organization who wanted to restrict access to the JSS management pages in a JAMF Cloud hosted instance? Correct? All right, just repeating the question. As I think of anything.
I'm actually not sure. I don't know exactly what options there are, to be honest, on how you can restrict that access.
Yeah, that
Because
might be
we
a better
didn't,
question for you.
we didn't really look at that.
I don't know if you
I guess you're talking about limited access mode, where only devices can check in, but other computers or users can't. If you're in a customized instance of JAMF Cloud, there are some options that we could talk about. If you're in one of the standard instances, it's probably not an option. But I guess we're talking about the authorization control. So I guess if there's a specific problem that you'd have with authorization, one of them that's big is the two-factor. And as we saw during the keynote, that's on the roadmap where we're going to have single sign-on, two-factor, stuff like that. So yeah, for now, I guess we can talk if you want.
Yes.
In regards to Filevault, I was under the impression that individual keys were better when you actually had to use them, because if I'm a remote person, I can call them and say, this is your key, unlock your Mac, and I can give you a new one, and then nobody else knows it again.
Yep.
So if that's part of my workflow, your recommendation kind of goes against that concept.
Well, our recommendation goes for, not so much for, I guess, it's in the context on how JSS handles the individual keys. It's like not, if you don't use JSS for that, and I guess, so maybe I should repeat the question first. The question was that individual keys can easily be given to somebody who's a remote worker and then changed afterwards, while obviously giving the institutional private key to somebody is not a great idea.
Yeah.
That seems like it's a bigger risk than the JSS, because it's a super connection between the client and JSS.
Yeah.
Yeah.
Definitely for remote workers. I mean, you don't want to give the private key to someone, that's for sure. I think the intended use case is more ship your laptop in and we decrypt it for you and give it back to you rather than we give the private key to somebody. But if that doesn't work for you, then you need to consider the other option for sure.
Yeah. And I mean, a lot of that is right. I mean, we test with a security mindset, right? We don't develop software, which is a much more usability thing, right? So when we're looking at something, we'll note if it's extraordinarily complex to do something, right? But our focus, we don't worry too much about, how easy or difficult it might be for any use case, much less a given use case, right? We really look at it from a security perspective. So, from the security perspective, the idea that, that the individual key is literally sending the password to the hard drive down on every check-in, pretty much, on every recon, that's an issue. We would have a problem with that regardless of pretty much what password was being sent down, right? But yes, it's definitely a much easier use case to just be able to call an individual person and say, here's your individualized password and change it, right? And that's kind of like why the Filevault part was even in the configuration kind of section of the slides, right? There are a lot of tunable parameters that you can tune one way or the other depending on what you need for your environment, versus what your risk tolerance is, right? Obviously we would never ever say, oh, instead you should ship your private key to your end users, because that would be crazy, right? You're aware of this issue. I don't think it's going to change your risk calculus at all, right? But it's good for you to know that this is the case, right? And that's our job really as third-party assessors to give information to JAMF, and then via them to you to just help you make your own decisions, right? We don't dictate to anyone this is how you have to do it. We'll say this is what we see, this is the problems, this is what could go wrong, and then it's up to the developers, the company to make the choice of how they're going to fix that. Sometimes it might be that, it's such a slight issue, like it's just a configuration change, that there'll just be a note in the documentation saying, hey, by the way, this is a more secure choice, but, if your environment doesn't support it, then do it the other way, right? So in this case, go ahead.
I'd like to just dwell on that for a second, because when you have all your eggs in one basket, like what's your procedure for changing that institutional key? Because there's real ramifications if you have support staff turnover, and wrapping it back to the choosing the right encryption protocol. I think it's even more important to think about how often are you willing to change it? Are you set up to actually change that institutional key? Are you actually set up to change out those certificates? So that's why I like taking the practice, the hygiene of security.
Yeah, that's kind of back to the slide I had about cryptography. One of the hard things about cryptography, once you get past all the what algorithm to use and stuff, is the biggest problem is key management, right? It's how do you generate your keys, how do you cycle your keys, how do you make sure that they're kept up to sync and they don't get lost, things like that. And it is, right? This is not something that's technically solvable in all cases, right? It's a policy decision. How are you going to do it? It's just like password policy, right? What is the strongest password policy you think your users will tolerate without mutinying, right? We could all say everybody should have, 4 character classes, 15, 16 character passwords, very complex, and users are gonna write them down or use the same password for every single site because they can only remember one, right? Is that a good way of doing passwords? No, that's why passwords suck. That's why a lot of industry is moving to two-factor authentication, right? Because it's much easier now to have a moderately strong password and a text message to your phone that should always be in your possession, most likely, or using something like an RSA ID, or on an iPhone using Touch ID to identify you as you, right? They add layers of security and configurations to make it easier for you to dial things tighter or weaker depending on your own environment, right? Everybody's environment's different, so it's not very easy for anybody to say this is how it has to be in all cases. Yes?
When you're doing the testing, are you just testing the JAMF software? Because I remember you said that you do most of your testing in the cloud environment. Are you actually testing the infrastructure of the JAMF cloud offering as well, like the Amazon S3 servers and stuff that runs on those?
Are we also testing the Amazon S3 infrastructure that JAMF Cloud runs on, as well as the JAMF software itself?
I am not sure if we have done an assessment for that, to be honest. We probably have done at least port scans and to see the host which is running JSS. We definitely have done that, but I'm not sure if we have looked at the overall infrastructure as a whole. I don't know if Jason knows if you have done that.
I'd say that's pretty accurate. The ports, anything that's externally facing, definitely. So like they've looked at what ports are available, what cipher suites we're using in the SSL, what protocols are supported. But as far as like testing the underlying infrastructure, no.
Yes?
What are your assessments and evaluations of JAMF's API? Obviously, it's a great way to inject information, maliciously or otherwise. I know you mentioned XML earlier, so that would be one example of taking advantage of that.
What is our opinion of the JAMF API, pretty much? I will defer because I don't know if we've tested again. Like I said, you've tested more than I have.
That's just part of the
It's just part
the
of
general assessment, yeah. It's just, we just treat this as a web service basically, and we'll test for anything which is web specific. So injections into databases or in LDAP systems, XML, potentially attacking some admin which can see the information you're submitting via the API, things like that. So we just, usually APIs are just treated as a web service, and we test it just for anything which is relevant to that.
And then anything we find, we've reported back and they've addressed, so. Any other questions? On the other side now, over here. Any questions? Way up here? Okay, up there. Does NCC or JAMF have a guide for hardening a JSS installation?
I think so.
I believe so.
Jason, you should know this better probably.
Yeah, this is actually something that's probably going to be made publicly available pretty shortly. In the meantime, we do have some internal documentation, so if you have any questions on that, you can contact your account manager and they can walk you through some of the best practices, but that will be something that's coming soon out to the public website as well.
Any other questions?
Yes, someone over here?
Good.
Yeah, so given the high privilege the JAMF library runs at, you guys have been hardening the operating system against custom firewalls.
So the question was if since the JAMF binary is running with high privileges, if there's any hardening which we would recommend. So the JAMF binary doesn't listen on any ports. It just connects out to things. So there is no way to connect to it directly. So from that standpoint, not really. From what we have looked at though is if you're a regular user on a system, could you use the JAMF binary to become root or something else? That's something we have looked at, and that's been pretty challenging, let's put it that way.
All right.
So just to add to that, currently our JSS is only available on our network, and we had a request to open that up to offsite. Any concerns that we need to look at there?
Are there any concerns with opening an off-site or an on-site JSS installation to off-site users? I guess it depends on exactly what you mean by off-site. Are you talking like internet-wide or just another wholly managed site?
Internet-wide, so that they don't have to use VPN access.
I mean, there's probably the same concerns we would have over any internet-facing software, right? I don't think there's anything specific to JSS that we'd be concerned about, right? I mean, we would just be concerned that, yes, you're opening up this internal server now to the unwashed masses of the internet who, might not treat it very nicely.
I think the main problems are communication security to ensure that you're using the most secure configuration there, and then are you using anything to download files to the hosts? Are those encrypted protocols? How's the authentication handled there? I mean, those kind of things for sure. But it doesn't, make
if
you don't have to expose it, don't expose it is, I guess, the best rule. But if you have a need for it, then it's just like any other software.
So probably just, if we just gave the distribution points access,
I don't know, that might be something that's a bit more in the configuration that.
Discuss that in more detail when you have like knowledge about all your systems, I think. Probably not the best way to answer the question to give you value out of this.
We got maybe one more question if there are any. Far right, all right.
So the question was if you have looked at Apple push notifications and the ramifications of opening up your firewalls to 17/8.
No,
I mean,
don't think so.
No. But you're running their hardware and their software on your computer anyways. No, I'm just kidding. Not really something I can comment on. I wouldn't know. Do you know?
No, not at all. All right. I think that's time, so
Yeah, I wanted to mention one more thing. If you do have any questions, you can Twitter, hashtag JNUC Security. There will be a security panel discussion on Thursday afternoon as well, one of the last sessions. So like if your questions that get answered, maybe limited access or opening it up externally, you can either go through that route. Otherwise, come find me, come find your JAMF buddy, and we'll go from there. So, thanks.
thanks.